So here we go, the upper ocean currents in the Eurafrican Mediterranean Sea. Okay, you can have a look at that structure. You can see some gyres. Okay, and these are year-round circulation patterns. There are some minor seasonal variations or so, but mainly these are year-round circulation. You know, you have anti-clockwise circulation patterns in some regions. Okay, and you have several gyres. Have a look at the names. They're even called gyres. Okay, you have currents. You have something which is known as a front, and I show you the front on the next slide. The Almeria-Oran front. In front, what is a front? Your neighbor comes knocking. Hey, what is a front? Well, I think I remember that a front is a region which separates water masses of different properties. So you have warm water on one side, cold water on the other side of a front. The front is the transition zone. Okay, all right. Let's have a look at some of these features. Okay, just jumping to the next. Okay, so let's have a look at the bottom figure first. The bottom figure shows you a very old satellite image. Okay, and we are at the Strait of Gibraltar. Okay, the Strait of Gibraltar, and white refers to cold water white to cold and black to warm water. And here you can see the front, the Almeria-Oran front. This front here, it's a quasi permanent feature. Okay, you have a very strong temperature difference of several degrees across this. You can also infer the existence of circular gyre type of structures here in this area. Okay, anyway, let's have a look now at the vertical structure. Okay, and the vertical structure in this area is best derived from salinity distribution. And they are shown here in the top panel, showing you over most of the Eurafrican Mediterranean Sea, the salinity distribution. Look at these numbers. So you might ask yourself, what is he talking about? Well, what I mean by look at the numbers is, what's the salinity that you find in the open ocean? Okay, so you say 35, 34, something around that. Look at these numbers. 38. Okay, we nowadays don't use units for salinity anymore because it's actually derived from something which is called a conductivity ratio. So electrical conductivity. And so anyway, so this one is equivalent to grams per kilogram of salt content. This is all hypersaline. I think you could even taste the difference between this water, hypersaline water, and open ocean saline water. It's all yuck, but you can taste the difference. So, all right, what can you see here? You can infer there is actually a structure of lower salinity water that can be traced back to the ambient Atlantic Ocean. There's an inflow of lower salinity water, and there is evidence here of an overflows of hypersaline water between the basins, but as you will see later on, also across the sill here in the Strait of Gibraltar. And this is what we call a concentration basin of the Mediterranean Sea. Why concentration basin? Because it's located overall in a climate which is more arid, and the water loses, or the sea loses fresh water to the atmosphere from evaporation, and this leaves the salt behind, and this creates a hypersaline environment. Okay,